Okay, thank you all for coming, and I'd like to applaud everybody's perseverance and dedication for getting to this room today. It was quite a haul, let me tell you. My Fitbit says 3 miles walked, and that was before noon, so at least it's healthy. It's good for us. So today I'm going to talk from an ingredient supplier's perspective. And I represent BASF, which, as you know, recently acquired Pronova. But I'd like to try and take an agnostic view, a non-biased view from the supplier perspective today to give those of you who are formulators and research and development people some ideas and some tips and tricks on how to formulate and how to create the maximum health benefit from omega-3 products. You know, it was really difficult in preparing this presentation today, so I just wanted to kind of get a feel for the audience before we begin. How many of you would say that you have, by a show of hands, less than 2 years of experience in the omega-3 space, just really quickly? Okay, we got about 30%, 20 to 30. How many between 3 and 10? 2 and 10. Okay, that's the bulk. And then how many more than 10? Okay, keep them up more than 20. Keep them up more than 30. I see a couple. That's why I love this industry. More than 20 years of experience still coming to a training session. So let me just give you a little background on myself. I've been in this industry for about 6 years. I was a product manager, so I know a little bit about the commercial side. I'm a scientific marketing manager now, so I've done a bit of delving into the research around omega-3. So I'd like to try and give a well-rounded view during this presentation. The key thing I'm going to talk about is maximizing the health benefits of our omega-3 products. And then basically I'm going to go into the supply chain, different production technologies for getting different products. And then finally, how can you as a finished good manufacturer differentiate your finished product? Okay, EPA and DHA. Everyone knows kind of what those two things are. There's some slight differences between EPA and DHA in terms of the activities in the body. But suffice it to say, both EPA and DHA are very important in the cardiovascular health space. And if you look at kind of some of the differences between EPA and DHA, what you see is that EPA tends to be more of an inflammatory mediator. DHA tends to be more of a structural fat in the brain and the eye. So that leads to some of the differences in their activities in the body. But suffice it to say that they do very similar things, and the body can interconvert between them as well. I mean, if you look at quality of life, there's really nothing more important to you than your eyes, your brain, and your heart. So really, I think that omega-3 really gets to the point of life. Some say it's a life elixir. Maybe I won't go that far. But why does EPA and DHA exert so many different activities in the body? It's because it integrates into every cell in the body, into the membranes of every cell. It is involved in the structure of the membrane. It provides fluidity to membranes. It integrates into brain cells to allow them to function better. And once in the membrane of every cell, it has the ability to release and to create anti-inflammatory signals. As you all know, inflammation is a key mediator to a lot of different diseases, which I'll talk about in a second. So that is one of the key activities that it does. It also has activities in terms of the signaling pathways in the body. So omega-3 can mediate gene transcription, which is basically the expression of your genes. It can change the expression of different pathways, which can reduce the triglycerides in the blood. by lowering the very low density lipoprotein particles, which carry those triglycerides, and shifting your cholesterol to a different basic configuration. But finally, there's some interesting research coming out about cell vitality as well, and a few studies on the shortening of telomeres, which is basically like an alarm clock for your cells. When that telomere gets to a certain shortness, the cell ends its life. And if you can prolong the life of that cell by lengthening those telomeres, you have a better cell vitality. And so, you know, this is very, very, I would say, not very proven research on the right here, but very interesting, I think, from a scientific perspective. So if you look at all of the different areas in clinical development for omega-3, and this is pharmaceutical development, what you see is that there's over 40 pharmaceutical targets in development right now for omega-3. The two that are approved right now in the United States are up here: high triglycerides and post-myocardial infarction, basically after a heart attack or those with very, very high triglycerides. This is an omega-3 drug. It's called Lovasa. Hopefully all of you have heard of it, but if not, please look it up. There are a wide variety of different other candidates in development, though. And so this is a very exciting field to be in. And I think that development in the pharmaceutical field is going to really float the boat of the dietary supplements field as well. So the goal here for this presentation is to make sure that we provide suggestions for formulators on how to maximize the benefits. I am not, although it may seem like I'm talking about one technology disparagingly over another, I want to highlight the fact that every technology, every way of getting omega-3 in the body is promoting health. And so I'm going to give some marketing ideas. I don't mean to say that one thing is better than the other. I'm trying to take an agnostic view, as I said before. So please take everything I say with that viewpoint. I will provide today, as you're sourcing from different suppliers, a top 7 checklist for different things to look at to get the best quality from your suppliers. And the goal here, and everyone I'm sure is interested in this, is to provide the maximum health benefit for our consumers. So let's break it down to the good, the bad, and the ugly. Really, the good refers to the omega-3 concentration in your product. And this is part of a checklist that you can all use in order to verify that you're getting the highest quality source. The bad is unwanted fats and cholesterol. Saturated fat tends to be a component that is in some fish oil products, and I'll talk about that in a bit. Finally, oxidation, which is basically the main topic of today, so I'll delve into that in some detail, is a key differentiator of different products, and it's part of the initial experience that a customer has with your product. And so it is very important from my perspective. And then finally, we talk a lot about impurities and talking about how to minimize those to maximize the health benefits. So let's talk about the good and the bad together. In terms of omega-3 intake, it's pretty well known that in the United States, we don't eat enough fish and we don't take enough of our omega-3 dietary supplements like we should. The average intake in the United States is about 120 milligrams per day of EPA and DHA. If you look at a suggestion from the Dietary Guidelines of Americans, they say you should be getting about 250 milligrams per day from fish. And similarly, the Academy of Nutrition and Dietetics suggests around 500 milligrams per day. I tend to think in the 500 milligrams per day is a good place to start. The American Heart Association suggests that people with heart issues take up to 1 gram or more per day. The FDA says that levels up to 3 grams per day of EPA plus DHA, totally safe for human consumption. So that gives you an idea of the different kind of levels. In my presentation, I'll be shooting for a 500 milligrams per day dose. So if you look in that 500 milligrams per day dose and you compare a natural fish oil with a very concentrated fish oil, we call it not a concentrated fish oil, but an omega-3, you can see that the omega-3 is the key component we're interested in. In natural fish oils, you have a lot of other items that come along for the ride, including monounsaturated fats, which may actually be beneficial to health, but definitely aren't the omega-3s. You have others, which include polyunsaturated fats, such as omega-6, which also may be beneficial in small quantities, may be not so beneficial in large quantities. And, of course, saturated fat, which many say is the bad fat. Although there's some research that's recently come out that said that maybe saturated fat isn't as bad for you as it's typically thought. But the dogma in the nutrition world is that saturated fat really is the cause of increased cholesterol and increased heart disease. So if you compare these two, what you see is that the levels of saturated fat in a concentrated omega-3 form are much, much less than those in a natural form. If you then change this to a soft gel, what you see is that in order to get that 500 milligram dose of omega-3, you need two of these bigger ones, 2 of these 1 gram soft gels. And with that one daily dose comes 500 milligrams of saturated fat, which on a nutrition label needs to be labeled as saturated fat if it's above 500 milligrams. And 18 calories. And if you add that up over a month, so that's 1 day, but if you add that up over a month, you can see that that starts to add up. And so if we want to kind of shift the paradigm a bit and shift where our customers or our consumers are really deriving the health benefits, we feel that providing a more concentrated format is where it's at. The amount of saturated fat drops by about 100-fold. But not only that, you're taking less oil as well. So you have less of those negative side effects, which are frequently talked about in the omega-3 world. It's also easier to take a smaller pill, and you're more likely to take them if you only have to take one versus taking multiple per day. So it's more likely to see the benefits, because if you're taking it every day and it's easy for you to take it, you're going to take it. That being said, even a natural fish oil, you're going to see health benefits from it, and I don't want to say that there's anything wrong with taking a natural fish oil. What I'm saying is there's some way that we can go from good to better. If you look at the overall market, and this is a little bit of an information-dense graph, but what you can see, and this is data that GOED published at the end of, or at the beginning of 2014, you can see the overall market volume is dropping slightly on natural fish oils and dropping slightly on concentrates, staying pretty stable in other forms, maybe a little bit up on krill. But the value is shifting very strongly from natural concentrates, from natural fish oils to high concentrates. And the fact that this volume is dropping, but that the value is increasing so much, means that not only are people staying in this field of concentrates, but actually trading up from a lower concentrate to a higher concentrate. Because as you trade up from a lower concentrate to a higher concentrate, you pay more. So here's the first 3 parts of our checklist. Trying to get the most omega-3 concentration, trying to get your saturated fat below 1% in your product, and trying to also drop your cholesterol below 4 milligrams per gram. Okay, now we talk about the ugly, and specifically on oxidation. Many of you may remember the old Head and Shoulders commercials where the lady's getting ready for a job interview and she's got flakes on her shirt, and then they say, oh, you should have used Head and Shoulders. Never get a second chance to make a good first impression. In this case, it's true for a fish oil capsule as well. So 59% of consumers, so this is in general, say that the first impression really makes or breaks a brand image. And 59% of consumers in the omega-3 space and in the dietary supplement space say that taste and smell are very important or somewhat important to their purchasing decision. But not only that, the taste and the smell of a product also gives an impression of the quality of a product as well. So quality and safety are also two of the top 3 reasons, and price is, of course, the number 1, so I'll let that be known. But quality and safety are 2 of the top 3 in terms of why a consumer picks a certain dietary supplement. So it really is important to make a good first impression. Minimizing oxidation is one way to improve the user experience. So I want to thank Steve for going into the details on oxidation, and a bit of a review here. Primary oxidation is when the oxygen hits the polyunsaturated fatty acid. Polyunsaturated fatty acid means that you've got a lot of very unstable double bonds in your product. So when oxygen hits that product, you start to form things called peroxides. So your measure of peroxide value, which Steve went into, so luckily I don't have to explain again, is a level of how much oxygen that product has seen, in a very simplistic way of saying it. Over time, if you expose a product to oxygen and then close off the source of oxygen, what you see is a spike in the peroxide value. And over time, that peroxide value will decrease as those peroxides start to react with the fats in the product and form secondary oxidation products. And these are the things, some of which smell pretty badly. They give you that rancid smell. They're called volatile secondary oxidation products. So you have 2 ways of telling, first, how much oxygen have I seen, plus how much rancidity has developed, with the peroxide value and the inositine value. And if you look at a typical C of A on a supplier raw material, you'll see the Totox value, which tells you it's the addition of 2 times the peroxide value plus the inositine value. That's the key. Okay. So GOED has a specification which we believe across the industry stands for a safe oil. And what I've been very impressed with is how the industry is responding and bringing specifications even lower than this minimum specification that's required. Or it's not a minimum specification, but it's a voluntary specification. And right now, the industry is moving such low Totox values. I'm seeing levels of 3 to 5 in some very, very good C of A's. So when you're looking at omega-3 products, you can determine this oxidation, how much have I seen and how much is developed over time by looking at this Totox value. But there's also a thing called oxidation drift. So we've done part of the way by delivering a product with low oxidation in the drum. But as soon as that drum gets opened up and oxygen rushes in, it's a whole new ball game. And so oxidation drift is from the moment it's delivered to the encapsulator or the brand manufacturer until the moment where it hits the soft gel capsule. How much oxygen gets exposed to that oil, and how do these totox values increase? The raw material manufacturer limited, when it supplied it to you, it limited oxidation as much as possible by keeping the temperature low, by keeping the exposure to metals as low as possible, by purging the process completely with nitrogen, keeping it closed and low pressure as much as possible. And we can take these things, these concepts, and extend them to the encapsulator as well. When you open up a drum of fish oil and you start removing omega-3 from it, air rushes in if you're not doing anything. And that air can have a very instantly detrimental effect to that product. So you want to purge that drum. You want to keep it as much as possible under nitrogen as you open it. Keep it sealed. When you're combining ingredients together in the medicine tank, it's very important that this whole process is done under nitrogen and that it's a sealed system as much as possible, and that all the other products that are involved also have been purged with nitrogen as much as possible. We need to also strive to protect soft gels from light and heat. So light is one of the contributors to oxidation in fish oil, and heat, of course, is the other one. One thing that I found was interesting, I saw somebody from BASF did a study in terms of the packaging of the soft gels. And the actual container that the soft gel is delivered in makes a difference. You would say, well, the soft gels shouldn't be that permeable to oxygen, so it's okay if you've got the soft gel. But it actually matters what container they're in and what's the headspace of that container as well. And finally, I think that our suggestions are that the PV is the most sensitive part of the process, and it gives you an instantaneous measure of the oxidation that develops in your product. So if you can check that PV after manufacturing, after some test batches, and try and continuously improve that process. Looking at some tests of market products of anisotine value, you can't really take this as gospel here, because what happens is if you put a flavor in, so anisotines are aldehydes and ketones which cause flavor and odor, right? If you put a lemon flavor in there, you're going to increase the anisotine value. So you can't just take a product off the shelf and measure it, because you may find that you're measuring not only the oxidation of the fish oil, but the additional anisotine of the flavoring. But if you look across the board, what you see is, there is some improvement possible in the industry with very strict controls of oxidation drift. Some of our partners have told us that they can control to a PV increase of 1 or 2. And as we know, PV turns into AV. So improving the sensory experience. It's about sourcing raw materials. It's about proper handling to limit oxidation in the finished product. There's also some things you can do to cover up a non-ideal situation, such as adding antioxidants. If you know that your process isn't going to be totally ideal, you can add antioxidants at the beginning to try and protect. You can do an enteric coating on the capsule, but we feel that not every enteric coating is 100% accurate. Sometimes when you take it with an empty stomach, you still get a little bit of issues. So avoiding that situation is really important. And then finally, addition of flavors does add a positive benefit to the experience for consumers. Is it unhealthy to take rancid fish oil? That's a question which is talked about a lot in the industry, but there's not a lot of scientific research behind it. And what I've been able to uncover is that oxidized fats, oxidized polyunsaturated fats from something like soybean oil, there's a whole review, and you can look up that paper if you want to see it. But there's a whole review on the effects of oxidized polyunsaturated fats. But nobody's ever, or there's been only very few studies that have shown what happens to you when you take oxidized fish oil. And it's not really conclusive evidence right now. There's one study that showed a slight increase in cholesterol. There's another study that showed no impact. But I think the worst thing that could happen to a consumer is that they stop taking omega-3 in the end, or get turned off from the category completely. So oxidation is, while it may not be a health problem, it still is very important for that initial experience. And if you compare 1 gram of fish oil per day versus the amount of grams of polyunsaturated fat in an order of chicken fingers, you're going to see that there's much higher amounts of oxidized polyunsaturated fat in an order of chicken fingers. So we add 2 more things to our checklist, toe tox less than 10, maybe even ideally less than 5 if you can find it, and prevent as much as possible oxidation drift when you open that drum. Finally, impurities. Before I talk about impurities, I just want to say that we all have a voluntary monograph as suppliers that we adhere to, which means that the product is safe. And so you're talking between safe and safer. Our goal really as an industry should be to minimize these as much as possible, but in the end, you're never going to have 100% pure product. It's not possible. And if you look at the impurities present in fish, they are orders of magnitude higher than what you see in fish oil, and I will present that data in a second. But the government still recommends that we eat fish, and they even say that pregnant people should eat more fish. So it's extremely important that we just kind of set the bar that, although there's impurities in these products, there's no safety issue. So it's between good and better. It's confusing for consumers because there's news articles that come out and say you can't eat fish. There's another news article that comes out and say go ahead and eat fish. It's even confusing for these fish. Look at their faces. I'm unhealthy? I thought I was healthy. These guys, not so much. They're pretty much done. The key is that persistent organic pollutants and heavy metals concentrate up the food chain. They reside in the fat of animals and in the muscle tissue. When one fish eats several fish, that fish will consume also the impurities of that fish. So there's a spectrum when you're talking about fish. It's not just this is safe, this is not. You're talking about some species that are more likely to have risk, some species that are less. This was a great graph in the Washington Post, and it shows the levels of omega-3 fatty acids versus the levels of mercury in a lot of different fish. For those of you in the back, all these fish at the bottom are big fish. Pacific bluefin tuna, shark, big-eye tuna, marlins. So it really is confusing for a consumer to remember all of these different things. Like, how many servings of shark can I eat a week? Hopefully it's not too many. Omega-3 fish oils do remove the guesswork, because not only are we taking the fish that are the lowest in contaminants to start with, but then further purifying those. Mercury is something that gets brought up a lot in the topic of kind of advertising fish oils. And it's actually, there's almost no difference among the lowest concentration fish oil and the highest concentration because it's actually very easy to remove from fish oil. So what you see here is the micrograms per serving of an albacore tuna in terms of mercury. And I think the recommendations for a pregnant person are 6 ounces of tuna per week. So that shows you that the government believes that the EPA and DHA content of that tuna is sufficiently positive to warrant a pregnant person eating 6 ounces of the tuna. The GOED specification is a level of 1,000 below it. So this is a log scale. I'm sorry, a level of 100. So that's 10. That's 100. But then when you actually compare where fish oils are versus that specification, what you see, and this is an average of the fish oils that were tested by GOED and Nutrisource, what you see is that that level is 10,000 less than a serving of tuna. So mercury is not really an issue. There's not really a big differentiating factor among suppliers. Still, look for results below 0.01 micrograms per gram in the mercury. And I've seen some suppliers that are now at 0.005 and less. PCBs. So it may be difficult to read this, but let me just say the Disneyland Resort contains chemicals known to the state of California to cause cancer. Can you imagine seeing that when you go to Disneyland? What that means. This is California Proposition 65, and it covers a huge list of different products, different chemicals that are known to the state of California to cause cancer. And this actually plays a role in labeling of fish oils that are sold in California. We have to be very careful in terms of PCBs because that's one of the items that's on the list, that the maximum exposure is not more than 0.09 micrograms per day. But if you look at the levels of PCBs in an average serving of tuna, what you see is that our GOED specification is about 100-fold less than a piece of tuna. And the best omega-3s in the industry are now 10-fold less than that. Okay, so this gives kind of a value for people to look for in terms of PCBs. At this level, 1,000 servings of fish oil are equal to a serving of tuna. Suppliers will look at a lot of different contaminants in their product. I was trying to count the number of contaminants in one of our reports, and it was more than 400. But of course, you're talking a lot about a lot of different chemical molecules. PCBs, there are 209 distinct chemical molecules called congeners, which make up the overall levels of PCBs in a product that you have to test for all of them. So it's very strict in terms of testing, and we can provide data for that for people who are interested. So this kind of fills out our overall checklist. Actually, it ended up being 8, not 7. Okay. You wanted to take a picture? Go ahead. Sure, no problem. So the next thing that I'm going to talk about is the supply chain and the production technologies. And at the end of this section, I'm going to have a graph which shows the costs and the omega-3 content of a large variety of different popular technologies in omega-3. So it's something that I haven't seen before in a presentation. I thought it was interesting when I was preparing it. Where do omega-3 products come from? Where are the top 9 kind of fish sources and algae and krill sources? You see right here, according to GOED data, anchovy is still by far the predominant source of the fish in omega-3s. And this doesn't come to a surprise for many of you who have been here for 20 years in the omega-3 industry. But I was surprised when I first came in about how important this anchovy fish stock is to this industry. It's a very well-managed fish stock, so there are government limits which are placed every year. And that means that there are some fluctuations in the price of that feedstock in terms of supply and demand. If there are heavier restrictions, then there are some price increases, and likewise if there is a more lax season. But suffice it to say that the sustainability of this is very well managed for long term. There are many other sources, and if there are any questions, I can get into them. But in the interest of time, let me just say that even 1% sources could be the future of this industry, and that this anchovy feedstock, while it has a very sustainable future, it may not be able to, if our government establishes a DRI and says that everyone in the United States needs to take 250 milligrams per day, it may not be able to cover all of the demands that we are going to have in the future. So these other stocks really are important. And we're constantly looking for new ways to get omega-3. The fish oil that we use from anchovy is actually a byproduct of the manufacturing of fish meal, which is a very large volume commodity in the animal feed industry. And so, don't worry about the details here, but basically this process is a simple separation process with a couple of other steps, which take this crude fish oil, which looks kind of like crude actual oil, and turns it into what you see on the shelf. Crude fish oil is settled, deacidified, bleached, winterized, deodorized, and then supplied as a raw material to the omega-3 manufacturers. How many people would like to know more about what the difference between ethyl esters and triglycerides are? Okay, it's not a huge amount, but it still might be useful. Triglyceride is the natural form of a fish fat, omega-3s in fish. And what you see is that usually the omega-3 fatty acid is stuck on this middle position of this three-part molecule. So in order to get a higher concentration than about 30%, what you need is to break that molecule apart. So you create an ethyl ester. So what you do is you break that molecule apart, creating an ethyl ester, and then you can distill the product to get it to the concentration that you want to. You can then recombine that back to a triglyceride by adding on a glycerol backbone with a catalyst. So it's very easy. So before I go into that graph, let me just say that ethyl esters tend to be less expensive, right? Because there's less steps that you need to do in order to get that product. Ethyl ester is the predominant form in Lovasa, which is the omega-3 pharmaceutical drug. So there is very strong measures of efficacy for ethyl esters. There are people in the industry that say that triglycerides have a slightly higher bioavailability. And that, may be a very true story. But over the long term, getting omega-3 is better than not getting omega-3. So whether it's delivered as an ethyl ester or a triglyceride, to me, most manufacturers will give you a choice as a formulator which one to buy. Okay. So crude fish oil goes through these various processes and then comes into a manufacturing facility. And what happens to it within this manufacturing facility is a concentration process, but also an addition of cost. And so there are so many different technologies out there in the industry now to make higher concentrated oils. I'm providing what I know about. If you have any issues with this graphic, please come see me because I'm constantly learning more about the industry. We start here, and just to get our bearings, with natural oils, which are usually less than $10 in price and usually around 25 to 30% concentration of omega-3. The typical standard for the industry is to take that natural oil and to pass it through a short pass distillation or a molecular distillation process. And there's really, I don't really know the difference between the two besides to say that short pass distillation tends to be lower in concentration, but also higher in pressure. As you decrease the pressure, you decrease the heat, and you are possibly able to increase the concentration more of that product. There are manufacturers that will then take that molecularly distilled product and do a next step to it, either urea precipitation to bump up that concentration higher, and urea precipitation can go from 70% to 80, 85, even 90%. They will pass it through a chromatography process, which bumps that concentration from something around 60 to 70 to 90, 99%. So there's two chromatography technologies up here, supercritical CO2 technology and HPLC technology. Both of them have their strengths and weaknesses. There's another route you can take. So this is kind of one route where you go up this hockey stick, right? There's another route you can take by concentrating the natural oil. You take that triglyceride backbone, and instead of breaking it apart, you do something to it like hit it with an enzyme that increases the concentration. Or you further take out saturated fats by bringing it to a very cold temperature. That's what we have here in this natural concentrates block. You can take that natural oil or a concentrated oil and microencapsulate it into a powder. Usually these powders are from 10 to 30%. That's really good if you're doing a food product. And you need to protect that product as much as possible from oxidation. Good part about encapsulated powders is you can open up the drum, and as long as you keep it in a pretty good place, you can still kind of maintain that product for a few weeks or a month or even 2 months in the best cases without having too much of an effect on the oxidation parameters. So it's easier to use from a manufacturer perspective. And then finally, we have krill and algae, which tend to be more specialized, higher priced, but also give very special marketing advantages to customers and to consumers. So we have kind of our buckets here. We've got technologies that you use to kind of have a special marketing advantage. You have technologies where you want to get into like a pharma-like space. You're giving the maximum concentration. And then you have kind of a combination of performance and cost here in this circle, which really is unbeatable in terms of just pure EPA content per dollar. Okay, I'm running a bit out of time, I think. How much time do I have? 5 minutes? Okay. So I won't go too much into detail on the processing technologies. I think they're going to be publishing this presentation, so I hope you all have a chance to look at it. I've got my card up here in case there are any further questions. I'll send it to you. I have a case study in here on BASF's Pronova Pure process, which is basically the traditional production of ethyl ester plus an additional step called stripping plus an extra step called urea complexation, which gives much lower saturated fat, much lower contaminant profiles. Okay. Finally, differentiating your finished product. So the supplier is here to help the formulator and the marketer to differentiate the finished product. And we can be a key partner in this process. We can give you tips in terms of what process steps we use are special. Very many manufacturers have special patents on their processes, which they'll share. There are some manufacturers that are better than others in terms of purity and oxidation specifications. Country of origin is also a very strong differentiator in the industry, and some of the most premium products use a country of origin as their main selling point. Different product forms like ethyl esters or triglycerides or phospholipids or glycolipids also can give a marketing advantage. Research using supplier ingredients. So many suppliers do clinical research on their products and can provide to their customers a list of such research. And finally, delivery formats. So a little plug for us at BASF. We've got 3 delivery formats in our booth. We've got a pixie stick. I don't know if everyone's familiar with what a pixie stick is. It's like a sugary, powdery omega-3 that you just put on your tongue. A little bit of a challenging application. We're, of course, showing very small soft gels in our triglyceride form. And we're also showing concentrated omega-3 emulsions for tasting. So please come by our booth. OK, and I'm available to give this presentation if anyone wants it at their site. So please let me know. Get in contact with me if you want to hear it again. OK, thank you very much.